I hope all of you are doing good. Let's start today's chapter, Lines and Angles. After reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. We have already studied about lines, line segments, rays and angles. Let us try to find the number of line segments and angles formed in the adjoining figure. Also try to find out which of the angles are acute, obtuse or a right angle. Can you identify lines, line segments and rays in the following figure? See, this is line, okay, this is also line, this is line segment because it has two end points, right? This is a ray because it has one end point and this is also a ray. So let us revise the definition of lines, line segment and ray, but before that remember, take care of arrows for line, line segment and ray, okay? See, if PQ is a line, then you will write like this. If PQ is a ray, then you will make an arrow, and if PQ is a line segment, then you will draw a line like this, okay? Line. A line has no endpoints. It can be extended indefinitely in both the directions. It is denoted by this, okay? Line is like this. You can extend it in both sides indefinitely. Next is line segment. A line segment has two endpoints and it has a fixed length. It is denoted by this AB. This is the line segment, okay? And we denote it by like this. Line segment is a part of a line. Next is a ray. A ray has only one endpoint and it can be extended only in one direction. It is denoted by like ray OP or OT, okay? So it has one endpoint, but we can extend it in this direction, okay? An angle. An angle is formed when two line segments meet or two lines intersect. Also, two rays originating from the same point form an angle. For example, see, this is an angle, your four angles are there, your one angle is there, okay? So when two lines intersect each other, four lines are formed. For example, this, okay? Two lines are intersecting, so how many angles are forming? 1, 2, 3 and 4, right? In the above figure 5.3 second part, lines AB and CD intersect at 0, O, and the four angles formed are angle AOC, this one, angle COB, angle BOD and angle DOA, okay? Pairs of angles. Number 1, complementary angle. Two angles are said to be complementary to each other when sum of their measurement is 90 degree. For example, if measure of one angle is 42 degree to each other, then the complement of this angle will measure 48 degree. Whenever two angles are complementary, each one is called the complement of the other, okay? No more. Answer the following questions in yes, no and give the response. It is possible that two right angles can be complement to each other? Two right angles. 90 plus 90, no. Two obtuse angles can be complement to each other? No. Two acute angles be complement to each other? Yes, okay. In the above figures, angle ABC and angle LMN are complementary pair. Okay, let's check out angle ABC and angle LMN. These are complementary pair, okay, and then angle DEF and then angle PQR, these are complementary to each other because the sum of these angles is 90 degree, okay. Number 2, supplementary angles. Two angles whose sum is 180 are said to be supplementary angles. For example, this is angle 50, this is angle 110, this is angle 70 and this is 130. So this angle and this angle are supplementary to each other because 50 degree plus 130 degree is equals to 180 degree, and these two angles are supplementary to each other, okay? 110 plus 70 degree is equals to 180 degree. So in the above figures, angle CD plus angle LMN is equals to 110 plus 70 degree is equals to 180 degree, and hence are supplementary. Also angle AOB plus angle PQR is equals to 50 degree plus 130 degree is equals to 180 degree, and so are supplementary. When two angles are supplementary, each is said to be supplement of the other. Can two obtuse angles be supplementary? No. Let us take an example to find out. We know an angle with measure more than 90 degrees called obtuse angle. Let one angle be 92 degree and other 95 degree. Their sum will be, what will be their sum? 92 plus 95 is equals to 187 degree. And 187 degrees what? Is greater than 180 degrees. So clearly two other angles are not supplementary. Can two acute angles be supplementary? We know that angle measuring less than 90 degrees is called an acute angle. So let us take one angle as 75 degree and other as 89. So both acute. So let's add them up. 89 degree plus 75 degrees equals to 164, and 164 is less than 180 degrees. So clearly two acute angles can never be supplementary. As one right angle is equals to 90 degree, so 90 plus 90 is equals to 180 degree. Okay, no more. Remember, two right angles are always supplementary, as one right angle is equals to 90 degree. Therefore, 90 degree plus 90 degree is equals to 180 degree. A very important point to be remembered is, if one of the supplementary angle is acute, then other has to be obtuse, and if one is obtuse, then other has to be acute, right? Number 3, adjacent angles. Two angles which share a common vertex and have a common arm are called adjacent angles. Okay. In figure 5.6 first part, angle AOB, this angle, okay, and angle BOC, means BOC, this angle, angle 2, are adjacent because both have a common vertex which is O and a common arm which is OB. Right, so adjacent angles share a common vertex and they also have a common arm, right? Remember, adjacent angles always have a common vertex and common arm, but two non-common arms are on either side of the common arm. And number 2, there are no common interior points in adjacent angles. Okay. In figure 5.26 second part, angle POQ and angle QOR and angle QOR and angle ROS are adjacent angles, as in angle POQ and angle QOR, they have common vertex which is O and common arm is OQ. Similarly, in angle QOR and angle ROS, O is common vertex and OR is common arm. Okay. Remember, angle POQ and angle ROS are not adjacent because though they have a common vertex O, but they have no common arm. Okay. So for adjacent angles, there should be a common arm, there should be a common vertex, right? Number 4, linear pair. A pair of adjacent angles is said to form a linear pair if their sum is 180. That is, adjacent angles which are supplementary are said to form linear pair. A linear pair is a pair of adjacent angles in which non-common sides are opposite rays. Okay. So in figure 5.7 first part, angle AOB and angle BOC are adjacent angles as they have a common vertex O and a common arm OB. Also, they are supplementary as they lie along the line AOC. Okay, thus here angle 1 and angle 2 are said to form a linear pair. Means angle 1 plus angle 2 is equals to 180, and the reason is linear pair. Okay. And in figure 5.7 second part, angle POQ and QO are adjacent angles but do not form linear pair because OP and OR are not opposite rays and hence are not supplementary. Okay. Example 1. Find the degree of measure of each of the angles in the linear pair shown in figure 5.8. Okay. See, these are the pair of linear pairs. So you will write 2x plus 4x is equals to 180 degree. Reason, you will write in bracket linear pair because both are linear pair, right? 2x plus 4x is 6x is equals to 180 degree. Now, what will we do? We will transpose this 6 to the right hand side, so we will divide here. So, x is equals to 30 degree. Okay, so x is the 30 is the value of x only. We have to find out 2x. Angle AOB. Okay, angle AOB is equals to 4x. That means 4 into 30 is equals to 120 degree. And next angle you have is angle BOC. BOC is 2x. That means 2 into 30 is equals to 60 degree. Okay. Now, if you add both these angles 120 and 60, you will get what? 180 degree, right? No more. Angles forming the linear pair are always supplementary. Okay, adjacent angles may be supplementary only when their sum is 180 degree. And number 3, supplementary angles can always be represented as adjacent angles, but adjacent angles always may not be supplementary. Okay. In example number 2, you have to find the complement of the following 25 degree. So complement, what will you do? You will subtract 25 degree from 90. Okay, and then you will get the complement. Okay. Example 3, find the supplement of the following 48 degree. So while finding supplement, what will you do? You will subtract this degree from 180. Okay, because you know the sum of two supplementary angle is 180, right? Number 5, vertically opposite angles. When two lines intersect at a point, 4 angles are formed. For example, okay, so this is angle 1, 2, 3 and 4. Okay, so here angle 1 and 3, 1 and 3, these are opposite to each other and these are vertically opposite angles, and so 2 and 4, angle 2 and angle 4 are also vertically opposite each other. So you can verify by paper cutting method that vertically opposite angles are always equal. So angle 1 is equals to angle 3 and angle 2 is equals to angle 4. Reason? Vertically opposite angles. Okay, vertically opposite angles. That's why these angles are equal. Try to locate one pair each of adjacent angles linear pair in the above figure. Let us try to prove geometrically that vertically opposite angles are equal. In this figure, figure 5.10, angle 1 plus angle 2. Angle 1 plus angle 2, as you can see, is equals to 180 degree because both are forming linear pair. Okay. Also, angle 2 plus angle 3, they are also equals to 180 degree because these two are also forming linear pair. Now, what will we from, this is equation 1 and this is equation 2. Okay, so what will we do? From these two equations, you can see angle 1 plus angle 2 is equals to 180 degree is equals to angle 2 plus angle 3. Okay, angle 1 is equals to angle 3. See, they will cancel out. Angle 1 is equals to angle 3. Cancelling angle 2 from both the sides. Similarly, we can also prove that angle 2 is equals to angle 4, right? Let's do exercise 5.1. In the adjoining figures, try to locate 3 pairs of each adjacent angles, number 2 linear pair and number 3 vertically opposite angles. Okay, so adjacent angles. So I will write only one pair only. Okay, so angle AOB and angle BOE, angle AOB and angle BOE. Okay, common vertex is O and common arm is OB. Okay, so you will write 3 more pairs. A part. Now second is linear pair. Linear pair. So which 2 angles are forming linear pair? See, linear pair means 180 degrees. So these angles are forming linear pair. That is angle COE plus angle EOB. Okay, plus angle BOA. Okay, is equals to 180 degree because linear pair. So you will find 2 more pairs. Okay, and number 3, vertically opposite angles. See, this angle is opposite to this angle, right? You can write it as angle COD is equals to angle BOA. Okay, reason is vertically opposite angles. So you will find 2 more pairs, right? Pair of lines. If 2 lines are given in a plane, they will either be parallel or intersecting. If 2 lines intersect, they will always intersect in one point. 2 lines L and M intersect at O. It means O is the common point of both the lines. Okay, this common point is called point of intersection. This one. These are parallel lines. Okay, they never meet anywhere, right? Transversal. A line which cuts two or more given lines in distinct points is called a transversal. Here the lines cut by the transversal may or may not be parallel. For example, this is the transversal line. Okay. In this case, this is also a transversal line. Okay. So in figure 5.12, first part, L and M are parallel lines and N is the transversal cutting L and M at A and B respectively. Okay. No more. Important point of parallel lines. Parallel lines do not meet. If they are produced in either of the direction, they will never ever meet. Okay. And if two lines are parallel, perpendicular distance between them is always constant. Okay. Then in figure 5.12, second part, P and Q are intersecting lines. Have a look. P and Q are intersecting lines and T is the transversal cutting P and Q at C and D respectively, right? Next, angles formed by a transversal. In figure 5.13, there are two lines AB and CD, okay? See, this is AB and this is CD, okay? And there is a transversal EF, okay, in two distinct points. Remember, AB and CD may or may not be parallel. Okay, it is not necessary that both these two lines are parallel. They may be parallel or may not be parallel. Okay, here the transversal EF makes 8 angles with the two lines. Okay, see how? Angle 1, 2, 3, 4. Now 5, 6, 7, 8. Okay, so there are 5 angles which are made by transversal EF. Now let us try to define these angles and also establish a relation between them. Number 1, exterior angles. Angle 1, 1, 2, 7 and 8 are the angles such that none of these contains the interior line segment PQ. Okay, these angles are called exterior angles. You can see that none of these interior angles lies in the portion between lines AB and CD, but lies on the outer side of lines AB and CD. As you can see, these two angles are outer side of DC and these two angles are also outer side of AB. Okay, number 2, interior angles. Angle 3, angle 4, angle 5 and angle 6 are such that their one arm is a line segment PQ. These angles are called interior angles. It is interesting to note that all these angles line the portion lying between the two lines AB and CD. This is the reason they are called interior angles. Okay, as you can see, angle 3 and 4, angle 6 and 5, these angles are lying in the portion lying between the two lines AB and CD. Okay. Number 3, corresponding angles. Okay, look at the following figures 1 to 4 carefully. See, angle 1 and angle 5, angle 2 and angle 6, angle 4 and angle 8, angle 3 and angle 7. These are corresponding angles. Okay. In above figures 5.14, 1, 2, 4, the pairs 1, 5. Okay, let's have a look. 1, 5, 2, 6, 3, 7 and 4, 8 are such that one arm of these angles is on the same side of transversal EF and the other arms are directed in the same direction. Here one of their arms is just an extension of either side. They are called corresponding angles. Hence, to sum up, a pair of angles in which one arm of both the angles is on the same side of the transversal and other arms are just the extension of the same line or directed in the same sense are called corresponding angles. Okay. Number 4, alternate interior angles. As the name suggests, these are interior angles and alternate to define a pair of angles in the interior of which one arm of each angle is on the opposite side of the transversal and the other arm is common and is the line segment PQ. The part of the transversal cut off by the lines A, B and C, D are called alternate interior angles. In figures 5.15 first part and second, angle 3 and 5, see, angle 3 and 5, okay, and angle 4 and angle 6 are alternate interior angles, right? Next is alternate exterior angles. a pair of angles in which one arm of each angle is on the opposite side of the transversal and the other arms are directed in the opposite sense, and none of these angles includes a line segment PQ, are called alternate exterior angles. Remember, alternate exterior angles include only exterior angles, none of them is interior angle. Okay, for example, in these two figures, angle 2 and 8 and angle 1 and 7 form two pairs of alternate exterior angle. Okay, let's do example 4. Name the pair of angles formed in the following figure under the following heading: corresponding angles, alternate interior angles, alternate exterior angles, and list of interior and exterior angles. Okay, so corresponding angles. Which are the corresponding angles? If angle 1 and 5, okay, 1 and 5, then 4 and 8, 4 and 8. Next we have angle 2 and 6, and then we have 3 and 7. So these are the pairs of corresponding angles. Okay. Number 2, alternate interior angles. Okay, now let's check out alternate interior angles. See, 4 and 6, second part, alternate interior angles. So 4 and 6 and 3 and 5, these are the alternate interior angles. Number 3 is alternate exterior angle. So alternate exterior angles, have a look, 1 and 7, okay, and 2 and 8. These are the pairs of alternate exterior angle. And number 4, what you have to write is list of interior and exterior angles. Okay, so first we will write interior angles. So interior angles are angle 3, angle 4, here angle 5, angle 6, and remaining are what? Exterior angles. Okay, means angle 1, angle 2, angle 7 and angle 8, right? Properties of parallel lines. In figure 5.19, AB and CD are two parallel lines cut by a transversal. This is the transversal. Transversal PQ in two distinct points, which one is R, one is S. Here corresponding angles are equal in pairs. Okay, so corresponding angles will always be equal. See, angle 1 and 5 is equals to angle 5, angle 4 is equals to angle 8, angle 2 is equals to angle 6, and angle 3 is equals to angle 7, because corresponding angles are equal in measurement, or you can say corresponding angles are equal. Also, alternate interior angles are equal in pairs. Example, angle 3 is equals to angle 5 and angle 4 is equals to angle 6. Similar reason, alternate, these are alternate interior angles, that's why they are these angles are equal. Next, alternate exterior angle, as you can see, angle 1 is equals to angle 7 and angle 2 is equals to angle 5. Reason, alternate exterior angle, right? Also, there are interior angles on the same side of transversal, they are called consecutive interior angles, and in case of parallel lines, these interior angles on the same side of transversal are supplementary. For example, 4 and 5. Angle 4 plus angle 5 is equals to 180 degree, and similarly angle 3 and angle 6. Angle 3 plus angle 6 is equals to 180 degree. Also, there are many linear pairs formed here as like angle 1 plus 2, angle 2 plus 3, okay, angle 3 plus 4, or angle 1 plus 4 is equals to 180, because these are linear pairs. Same way, we have 4 pairs of linear pairs here at point S, right? No more. If two lines are intersected by a transversal in two distinct points, and if either of the following is true: number 1, corresponding angles are equal; number 2, alternate interior angles are equal; number 3, interior angles on the same side of transversal are supplementary, then the two lines are parallel to each other, right? Let's do exercise 5.2. Identify the following pair of angles in the figure given below. Number 1, corresponding angles; alternate interior angles; number 3, alternate exterior angles; 4, pair of interior angles on the same side are transversal, and number 5, vertically opposite angles. So students, I told you, as I taught you in this example, right, how to find corresponding, what are the corresponding angles and alternate interior angles. Similarly, you will do this question also. Here one more part is added, has been added, vertically opposite angles, means angles which are opposite to each other, means angle 2 and angle 4 are vertically opposite each other, angle 1 and angle 3 are vertically opposite each other. So you have to just find out the pairs. Similarly, 6 and 8, 5 and 7, right students? Now you will do practice of remaining questions and this chapter also.